Hello all. Hope you are doing good and busy preparing for your public examination. Already we saw 3 videos related to your light chapter, and now today we are going to see few problems related to your reflection, refraction. And I hope this video will be very useful for you during this time, particularly for preparing for your exam, so that you can quickly go through your formulas and get registered to it. So let's see the first problem. So the coin placed at the bottom of a tank appears to be raised when water is poured into it. Explain. So what is this question is actually? So you take a beaker, okay, or a glass, a tumbler of like a glass tumbler, and then you place a coin so that you have to take a glassy material so that you can visualize from outside. So when you pour a water, not to the full tip of your glassy material, to just the middle portion of your glassy material. So what will happen actually? Will you see the exact position of the coin, or you're going to see the refracted part of the coin? So let's see. So this is just a picture of it. You can see the coin very well here. Can you see the coin here? And this is nothing but your water. The coin after water. So what is this coin actually? Can you tell me what is this coin actually? So what happens is this is because due to your refraction of light. Like as a light passes from water to air, right? So from here you are seeing, right? So as the light passes from water, can you follow the arrow mark? So as the light passes from water to air, it bends away from the normal. Actually we read all these things as a rules, right? So when a particular light of intensity traveling from air to water, it moved towards your normal line. But it is in the opposite when a light passes from water to air, it bends away from the normal line. You can clearly see from this diagram. So the refracted ray appears to come from a point above the actual position. So this is your actual position, but the refracted ray is coming out from where? It appears to come from a point above the actual position of the coin. Hence the coin appears to be raised. Hence the coin appears to be raised. So you can just try at your homes too. You can see the actual push of the coin is over here, right? The actual portion of the coin is over here, but you can visualize that the coin has raised little bit. That is due to the refraction ray. Refracted ray appears to come from a point above the actual position of the coin. So that is the exact reason for this. This is a reason. Like this occurs due to the phenomena of refraction of light. Here, the ray of light from the coin travels from a denser medium to a rarer medium. So, what is your denser medium? Your denser medium to a rarer medium. So, the ray of light from the coin travels from denser medium to a rarer medium. So, in this process, it bends away from your normal. That is from your water to air. So the point from which the refracted ray appears to come gives the apparent position of the coin. That is not the actual position. It is just the refracted ray coming out. Right. So that is the apparent position of the coin. So as the ray appears to come from the point above the coin, so the coin seems to be raised. So this is the theory behind this. Okay, so the two main factor in this is whenever a ray of light travels from a denser to a rarer, it always bends away from the normal, and the refracted ray appears to come from the apparent position of the coin, not the actual position of the coin. So this is the reason why the coin seems to be raised. So next is a 5 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 20 centimeter. The distance of the object from the lens is 30 centimeter. So we have to find the position, the nature, the size of the image formed. And I've given you the picture of it. Can you see? So whatever in the upward, we will take it as a positive, the sign convention. And whatever towards the left, we will take it as a negative. So this part, when it is in upward, okay, we'll take it as a positive. And when it is in left hand side, okay, so when it's left hand side, we'll take it as a negative. And towards your right hand side, it will be taken as a positive thing. So now, and I'll detailedly explain about the sign convention. So now, what is your given object size? You have to write all these data before proceeding with your formula. So what is your object size? Your object size is 5 centimeter, and your object distance from the lens. So that is towards your left. So towards your left, so it's always your negative thing. So only we have given like u is equal to minus 30 centimeter. And the focal length f will be your 20 centimeter. So we have to find the image distance v. We have to find the image distance v. So using this lens formula, so you already told all these in your past video. Alright kids, in your past video. So 1 by f is equal to 1 by v minus 1 by u. So now we are going to find only your image, right? So you keep this image data over here and you just bring this minus 1 by u to the other side. So when you just bring this minus 1 by u to the other side, it will become plus 1 by u. So can you see from this? So 1 by v is equal to 1 by u plus 1 by f. And what is your u? Your u is minus 30. So 1 by minus 30 plus 1 by 20. What is your 20? Your focal length, right? From the question. So this is a simplification. You have to simplify it. So how will you simplify it actually? You have to take an LCM. So what will be 30, 20? It will be 60, right? So I need to multiply the particular number. So what number? If I multiply with 30, I'll get 60. So it is 2, right? So it is 2. So 30 into 2. So the numerator also have to multiply with 2. And here 2. So here I'm going to multiply it with 3 because 23 is only 60. And in the numerator also I'm going to multiply it with 3. So if I do so, I'm just including my negative sign to the numerator. So it will be minus 2 plus 3 by 60. So that will be, what is your minus 2 plus 3? It will be 1 by 60. So 1 by v is equal to 1 by 60. So when I cross multiply these terms, I'll get 60 is equal to v. So this will be your position of your image. That is your part 1 of your question. And here you have to note one thing. If the sign conversion, the Cartesian conversion is wrong, like if you are taking u as positive and focal length as a negative, right? So you'll end up with the wrong answer. So the important thing is you have to choose the sign very, very cleverly so that you will reach your answer, right? So next is your magnification. So what is your magnification is actually, it is nothing but like V by U. So what is your V? 60. And what is your U? That is your image size by object size. We already saw this. So 60 by minus 30, it will be minus 2. Or it will be like hi. So the height of the image by the height of the object, that is equal to minus 2. So they are asking your height too. So how the image will be. So hi by, so what is your h naught? Your object size. That is your 5 centimeter. So hi by 5, that is equal to minus 2. So if I rearrange, like keeping a hi here, I'm just cross multiplying this. So I'll get hi is equal to minus 2 into 5. That will be minus 10 centimeter. So from this, what did I conclude is, I already clearly shown in the tabular column in the past videos. So you can have a look over it. So now the image is real inverted and it is magnified. So this is how you have to you have to write a problem. So if they are asking you a problem, you need to write like this. So first you have to write the given data. Next, the formula part is very important, and the simplification also they'll see to it, and you have to conclude that. So whatever they are asking, like part 1, if they are asking, means you have to write this is the part 1 of the question. Next the part 2, next the part 3. So this is how you have to write. You have to be clear with your sign conversion, you have to be clear with your formula, you have to be clear with the data, and you have to conclude the answer clearly. Got it? So this is an easy simple problem. And next is, I'm going to give you a homework. So you just try this problem. It just is the same problem we saw lastly, right? So we saw just now. Okay. So just do it and comment your answer. Fine. So now it is same similar problem. So if you have any doubt, you can just text me in the comment box. So now, next is, I already told you about the Cartesian shine conversion, right? So for spherical mirrors. So here is your thing. So can you see from this picture? So here, can you see, you already know all these things I taught you, but even though when you go through in this video without the knowledge of sign convention, you may not be able to proceed with the problems. So all the distance in a ray diagram or measured from the pole of a spherical mirror. So this is your pole, right? So pole of a spherical mirror only, we'll measure all the distance. So now the distance measured in the direction of the incident light is taken as positive. So in the direction of the this is the direction of the instant light. So whatever distance which is measured in like it related to the direction of incident light, no, so that will be taken as a positive. So the distance measured in the opposite of your incident light, that is the opposite of the incident light, that is towards the object. Can you see from this picture? That is opposite of the incident light, that is towards from your object. You can see that towards from the object, you can see that it is taken as a negative. So whatever distance which is like whatever distance we have to measure, no, that is if it is in the direction of the incident light, it is taken as a positive, and whatever distance measured in the direction opposite to your incident light is taken as a negative. Simple. Okay, so towards the incident line, it's taken as a positive. Away from the direction of the incident light is taken as a negative. And the height measured upward and perpendicular to the principal axis. So the height measured upward. So which is perpendicular? This is your principal axis, right? No. This is your principal axis. No. So when the distance measured in the direction opposite to the direction of the incident light or taken as a like upward and perpendicular to the principal axis of the mirror are taken as a positive thing. So the height measured upward. Okay, fine. So whatever height you are measuring upward and perpendicular to the principal axis, it is taken as a positive. and the height measured downward, which is also perpendicular to the principal axis of the mirror, is taken as a negative. That's it, the sign conversion. Towards the instant light, left and right, like your right hand side will be your positive, left hand side will be your negative, and top, like the top portion above the principal axis will be taken as a positive, and the bottom portion, downward portion of the principal axis will be taken as a negative thing. And here is your another important question. That is, Rohit placed a pencil perpendicular to principal axis in front of a converging mirror of focal length 30 centimeter. So how he is placing a pencil? He is placing a pencil perpendicular to the principal axis and in front of the converging mirror, not at the back, in the front. So now the image formed is twice the size of the pencil. That is your object. This is nothing but your object. So the image formed is twice. So 2u. You'll write as 2u because u is your size of the object. So calculate the distance of the object from the mirror. So I need to calculate how much distance. What is your distance actually here? They are asking your focal length. That is your distance between your focal length and the pole. So the distance of the object, okay, so the object distance u from the mirror. So now what is your magnification? Your magnification is equal to hi by h naught, which is equal to minus v by u. So for real image, this condition also we have learned. For real image, your magnification will be always negative. And for the virtual image, the magnification will be always positive. Since your formula is minus v by u2, okay, minus v by u, but for the real image, the magnification will be negative. Okay, and for the virtual image, the magnification will be positive. So now m is equal to minus v by u, that is equal to minus 2. Okay, so v is equal to 2u. So the negative, this negative will get cancelled. So you'll get v is equal to 2u. I'll just cross multiply. So now using the mirror equation, 1 by v plus 1 by u, which is equal to 1 by f. What is your 1 by v? Your image is nothing but 2u. So I'm going to apply it here. So 1 by 2u plus 1 by u is equal to 1 by minus 30. You know how to simplify this, right? Just an LCM. So 1 by 2u, you already have 2u. So here, what will be the LCM? You have to multiply this side with 2 because here you have only 2u. So it will be like 2 into u and 2u. So it will be like that is equal to 1 by minus 30. So now, what is this actually? 3 by 2u, right? So, 3 by 2u, that is equal to 1 by 30. Next, what can I do? I can just cross multiply. So, here also I'll cross multiply. So, 2u into 1, it will be 2u. That will be equal to 3 into 30, it will be 90. I missed the negative sign here. You just take care of it. So here you will have a negative sign. So 2u is equal to minus 90 and from that you can do it. So u is equal to 90 by 2 and u will be equal to, ultimately it will be equal to 45 centimeter. So it is negative 45 centimeter, which is in between. So negative, you know, right? So it will be away from your direction of the incident light, left hand side. So which is in between the focal length, between the focal length and the curvature, radius of curvature. So for virtual image, I told you it will be your positive. So m is equal to minus v by u is equal to 2. So the negative sign is taken over to the other side. So V is equal to minus 2U. Now using the same mirror equation, what will be my V? 1 by minus 2 plus 1 by U, that will be equal to 1 by minus 30. So yeah, it's the same method I used over here. So 1 by minus 2U plus 1 by 1 by U. If you take an LCM, we'll get 1 by minus 30. So is equal to 1 by minus 30. So if you do all those simplification, you'll get U is equal to minus 15 centimeter, which is in between the focal length and the pole. Right? So we got like two kinds, that is your for real image and for your virtual image. Got it? Okay, so using this information only, we are dealing with complete problem. Only we know the focal length of the mirror, that is your 30 centimeter. So with the help of the focal length of your mirror only, we did all these two things by calculating the distance for both your real image and for your virtual image. Got it? Next is the refractive index of a ruby is 1.71. What is meant by this statement? And the refractive index of some medium are given below. Crown glass 1.52, water 1.33, sapphire 1.77. In which of the medium is the speed of light maximum, minimum? Calculate the speed of light in sapphire. So I already given all this datas in your last video. So if you're not like seeing that, you can just go and watch my last video so that you know what is these values are. And now they are asking the refractive index of ruby. So that will be 1.7. And what is meant by the statement they are asking? And they are giving the refractive index for some other medium. So in which of the medium is the speed of light? Like if you take water, if you take a sapphire, if you take a crown glass, in which of the medium your speed of light will be maximum and your speed of light will be minimum. So calculate the speed of light in sapphire they have asked. So we'll just do it. So yeah, the answer for your first part. So the refractive index of an optical medium is a ratio. It's given by speed of the light in air to the speed of a light in any optical medium. So the refractive index of ruby is 1.71, which means the ratio of speed of light in air to the speed of light in ruby is only equal to 1.71. So whatever the speed or the ratio of speed of light in air to the ratio of the speed of light in ruby, that is only 1.71. That is only a refractive index value. So next they have asked, next they have asked like in which medium it will be like maximum and which medium it will be like a minimum your speed. So generally your refractive index is given by this formula, speed of light in air by speed of light in optical medium. So always we'll just take the medium related to your air to the any optical medium. So speed of light in optical medium is equal to, so when I want to find what will be the speed in the optical medium, I can just rearrange my data. So the refractive index will come over here, your speed will go over there. So it will be speed of light in air by a refractive index. So higher the refractive index, lower the speed. From this you can see. So if the refractive index is lower, your speed of light in the optical medium will be higher. So the speed of the light in the optical medium is higher, the refractive index will be lower. So the speed will be maximum in water and lowest in sapphire if you just go through your values. So now speed of light in sapphire I need to find. So speed of light in air by a refractive index of the sapphire. So now I'm using this formula. So just you know what is your speed of light in air? It's nothing but 3 into 10 power 8 by 1.77. So it's general thing. You have to just divide it by taking up with the decimal point, or with the decimal point also you can work out and divide. So you'll get 1.69 into 10 power 8 meter per second. Got it? Next is your, an object is 5 centimeter in length. An object is 5 centimeter in your length. Like in length means what they are telling, 5 centimeter in length. Actually, it is your height, which is held 25 centimeter away from the converging lens, away from your converging lens. So tell me whether it will be positive or negative. It will be negative because it's away from the converging lens. Of focal length also they have given. Okay, focal length will be always positive for your converging lens. That will be 10 centimeter. So we have to draw the ray diagram. We have to draw, like find the position, size, and the nature of the image form. So what did I tell you actually? You have to just tabulate all the known details with the sign conversion. That is, your object distance u will be your minus 25 centimeter. Your object height, that is your length, that will be your head's 5 centimeter, and your focal length will be your plus 10 centimeter. These three things are very, very important, which determines your sign convention. So according to the length formula, 1 by f is equal to 1 by v minus 1 by u. So we have like we have to find the image, right? Position of the image. So I'll just keep my 1 by v here. So I'll just take your minus 1 by u to the other side. So I'll get, yeah, I'll get like 1 by v here. So I'll get 1 by f. So if I'm going to take this minus to that side, I'll get plus 1 by v. So here why it is negative means actually it is plus only. Plus into minus is plus only. But my object is minus 25 centimeter. Okay, so plus into minus it will be plus. So 1 by 10 minus 1 by 25. So here also the same thing only. Okay, so you have to take an LCM. So if I take an LCM, so what will happen is nothing but you'll get 15, like 25. 25 minus 10, it will be like 15 by 250, or it is 1 by V is equal to 15 by 250, right? So it is just nothing but 1 by V is equal to 15. 15 by 250. If I want V is equal to 250, like if I want V, I'll just reciprocate it. So it will be 250 by 15. So if I divide that, I'll be getting 16.66 centimeter. So this will be like this shows the positive value of V shows that the image is formed at the other side of the lens. That is before the lens. Okay. So next is your magnification. So image distance by object distance, that will be is equal to V by U. So you know what is your image distance. That will be 16.66 by your object distance will be minus 25. So that will be equal to minus 0.66 if you divide. This negative value shows what? The image is inverted. The image is inverted. So now the magnification, but the magnification we have m is equal to image height by object height. I don't know the image height, but I know the object height. That will be 5. So if I rearrange it, that is, I know my magnification. What is my magnification? Is minus 0.66. So when I rearrange, okay, so h prime will be here. When I cross multiply m and 5, I'll get minus 0.66 into 5. I'll get 3.3 centimeter. So the negative value of image height indicates that the image formed is inverted. You can see very well over here. The image formed is inverted. The position and the size and the nature of the image are shown along the side of the ray diagram. It's clear now. So here, this is your image. That is like it is on the other side of the lens. This is your object. So only it is like it's opposite to your incident light. So only it is taken as negative. Got it? Okay, it's an easy thing only. Next is the people like the who have the eye defects, right? So you who have eye defects, the doctor has prescribed a corrective lens of power. Okay, so the corrective lens of power plus 1.5D. Find the focal length of the lens. Is the prescribed lens is diverging or converging? So what lens he has prescribed? Okay, so that we have to see what lens he have prescribed. So now here power, what is the power they have given? Positive 1.5 diopter. So we know the relationship between the focal length and the power of lens. So F is equal to 1 by P. So that is equal to 1 by plus 1.5 diopter. That will be equal to, so I want to remove this decimal point. So if I want to remove, I have to multiply with 10, right? So in the numerator also I need to multiply with 10. So if I do so, I'll get 10 by 15. So if you just divide it, 10 by 15, which will be equal to 0.667 centimeter, and they are just rearranged the decimal point by just multiplying with 100, so that they'll give you'll get 66.67 centimeter. So this is your easy problem. That is, when the power of the lens is given, you can easily find the focal length. But when the focal length is also given, you can easily just find your power of lens. So that is the problem. So here, if the focal length is if the focal length is increased, okay, your power of lens will be decreased, right? If your power of lens is decreased, your focal length will increase. That is your vice versa. That is, they are both are inversely proportional to each other. Find the power of a concave lens. I am given the focal length 2 meter. So as it is concave, I told only for convex your focal length is positive. As it is concave lens, the focal length will be F is equal to minus 2 meter. So the power of the lens P is equal to 1 by F. That will be, so P is equal to 1 by minus 2 meter. So it will be, you know that, right? So minus 0.50 diopter. So P is equal to minus 0.5 diopter. Therefore, the power of the given lens is minus 0.5 diopter. Next is name the type of mirror used in the following situation. Okay, so the headlight of a car, a side or rear view mirror of a vehicle, solar furnace. Support your answer with reason. So in headlight of a car, the concave mirror, to get a powerful and parallel beam of light, we are using that. And inside rear view mirror of a vehicle, we are just using convex mirror because it always gives an erect image and enables the driver to view much larger area. That's why we are using convex mirror as a side mirror of a vehicle. Then in solar furnace, we are using a concave. We can also tell it as a parabolic mirror. So concave or a parabolic mirror, because it can concentrate the sunlight at the focus to produce heat in the solar furnace. These are the questions they're just asking repeatedly. Okay, so next, you can try the sample questions from the past year, and you can comment your answer in my comment box. So these are the important questions in this light chapter, and they keep on asking these questions repeatedly. So you can find any one of the questions from the questions I have given here in your public examination. You can expect it. So you can just go through these questions, okay, and you can just analyze yourself that you are able to reproduce the answer for the particular question. Okay, buddies. So just try these sample question from the past year question paper and just comment your answer. And I'm just waiting for your answers. Okay, so hope this video was very useful to you, and it will just hardly take half an hour to spend on these problems. So you just go through these questions and just check that you can answer all the questions correctly. Okay, so what we saw from this video, we saw problems related to your light, that is your reflection and refraction, all your important problems. Okay, so thank you, buddies, and I'll be seeing you soon with my other video. Thank you.